Hi, welcome back to another video, and in this lesson we're going to go over quadratic functions, aka the parabolas, okay? All right, so the main takeaway from this is that you know how to identify the vertex, and the vertex is basically the middle of your parabola, like this little part right here. You can think of it as the like in the last video, you can think of it as the center, like how the center was to circles. With parabolas, we also have a somewhat of a center, but it's called the vertex. It's the middle of your parabola. So let's see. Okay, all right, let's go ahead and begin. So if you can identify, in a lot of these, if you can identify the vertex, you're halfway there. You just have to know which way the parabola goes. So we have 4 parabolas here, and we have to match the correct one. So let's see if we can do it. Okay, we're gonna explain the formulas as we go, as you know how we do things. All right, so let's go ahead and start. This vertex right here, doesn't that look very, very close to this one up here? This right here is called the vertex form. Maybe they're gonna call it something else. I could have sworn this was the standard form, and this is the vertex form, but we'll see if they use the same terminology. Okay, so this looks like the vertex form, right? And they call it that because just by looking at it, you can tell what the vertex is. So you see we have a negative h, and if you recall from the last video, whenever you have a negative inside of your formula, that means you take the opposite of what you have there. And we have the k. The k is just the k. So whatever your k is, there's no funny business. You don't have to take the opposite. It is what it is. Okay, so we have h and k. So your h here is the opposite of what you have here. So your h here is going to be, let's go ahead and write that thing down. So this is for h of x. Let's use a different color than the notes up there. All right, so h of x is equal to x minus 4. The whole thing is squared, and then plus 1, right? So what is our h here? The h here is going to be the negative 4, the opposite of negative 4. So we're going to call that vertex. Very similar to center, but it's not a center. There's no such thing as a center of a parabola. We call it vertex. So the vertex is, the opposite of whatever is here, which is positive 4, comma, and your k is always sitting out here, which is a positive 1. So if you don't see 4 comma positive 1 in here for your vertex, then you know that can't be it. And let me show you how that will look. So 1, 2, 3, 4. I will do a 5 by 5. So we have 4 comma positive 1. So 1, 2, 3, 4 positive 1. Let's use a different color. 4 comma 1. Somewhere right here. This is where you're gonna have the nose of your parabola, or whatever they call it. Okay, so the vertex. So now what? Well, we can just plug in any number that we want, and that will give us our parabola, believe it or not. You know what? Without plugging too much in, do we know the direction in which this parabola will go? I'll tell you. You probably already know. But take a look at the formula, the vertex formula up here, like right here, right? So look at your a, the number that's outside, directly outside the parentheses being multiplied. If it's positive, like ours is right here for the h of x, then basically you're going to have something like that. And this is just a rough sketch. Okay. If it was negative in front, you're going to see it's going to be upside down, going the opposite way. So we should have a parabola that looks very, very close to this, that has a vertex. The vertex absolutely has to be correct. Okay. Every point should be correct, but I want to say the vertex is the most important, which, take that with a grain of salt. I'm just trying to tell you the importance of that vertex. Anyway, so do we have a vertex that's at 4 comma positive 1? Yes, we do, right here. So we're going to put that right there. If you compare the other vertexes, this is like negative 4 comma positive 1. This is negative 4 comma negative 1. And this is 4 comma negative 1. So they all have different vertexes. So, vertices. That's the plural version of vertex. I'm a math guy, not an English guy, but I try. Okay. Let's see. And let's just find all the vertices. So this vertex will be at negative 4 comma 1. So if you see negative 4 comma 1, you're good. And there it is. because from 0, 0, you go -4 and then up 1. So that's it. This would be opposite, +4, -1. So positive. That's it right there. So that's really nice of them to give us a little, you know, exercise. This is -4, -1. So left 4, down 1. Yep, that's it. So yep. Excellent day. And we're gonna move on to the next one. It says, in the following exercise, find the coordinates of the vertex for the parabola given by the quadratic function. Okay, so they threw a 3 here, but we don't look at the 3. We only look at the inside of the parentheses to get our h. We take the opposite of what we see there, and the k will just be out here, which is a +1. If you see a minus or a plus sitting here to the right-hand side, then that would be your k. So don't pay attention to the 3. If anything, the 3 is your a, right? So that's not part of the vertex. Remember, vertex is h and k. So your h will be +9, and your k will be +1, because the opposite of -9 is +9, and all right, next question. Okay, we need the vertex, and check this out. We don't have any parentheses here. It's not in vertex form. It's actually in standard form, ax squared plus bx plus c. There are 2 ways you can go about doing it, and you see here where I have h is equal to -b over 2a. So I know I have a lowercase b, but b is b, okay? I probably should have made those into capitals to stay consistent, but you get the idea. You can use these 2 formulas. You can do -b over 2a and plug that thing in so you can get your k. Let's see, are they going to make us make a... Yeah, let's go ahead and do it. Might as well. Okay, so the vertex, and this is going to be good practice for you. So let me put blue ink. Okay, so we have f of x is equal to 3x squared minus 12x plus x. So here's your a. I'm going to use lower cases because it's smaller. A, your b, and your c, right? Right. To find your h, you do -b. So your b here is -12, so you keep the signs, okay? Divided by 2 times whatever your a is. Your a here is 3. We have a negative times a negative, which you know is a positive, so we get +12 on top. Down here, we have 2 times 3, which is 6, so we get a 2. So your h is equal to 2, right? Now, how do we find our k? You see this weird-looking formula here? It says to find your k, you plug your h into your function. So whatever your h is, which you know is x, wink, wink, h is x, right? When you want to find a y, don't you plug in your x? So if you want to find your k, you plug in your h. And it's the same thing, tomato, tomato. So let's go ahead and take this 2, and we're going to plug it inside of our function. So we need to find what f of 2 is by plugging in the 2, which was h, and just, you know, just go ahead and solve and simplify. So 2 squared is 4, 4 times 3 is 12. This is -24 plus 6. So this is -12 plus 6, which you know is -6. That is our k. So when we plug it in, we can say this is k. We can say k is equal to plugging in the h. Remember, this is an h technically. And we are done. So your k is -6. And that is the vertex. Let's see if that's all they wanted us to find. Okay, so your h comes first because it's x, and then your k is -6. Just like that. Bam, nice work. Okay, same thing here. So -b over 2a. I want to show you something in the graphing calculator. If you're allowed to use the graphing calculator, that's great. We're going to do -b over 2a and plug it in. I want to show you how to find these things in your calculator because, you know, you want to make your life easy, right? So let me activate the calculator. Bam. Okay, so check this out, right? Hit the y equals button. Let's erase this. Type in your function. Remember, choose this as your negative. Don't choose the minus symbol. You see how one is longer than the other? You want to use the negative symbol, okay? The minus symbol separates terms, but when you're writing one term at a time, you want to put, if that's your first term, you want to put a negative. So get into the habit of knowing when to use a negative and when to use a minus. Plus, Let's see. Oh, okay, plus 8x. And then plus 8. So I'm going to show you a little trick here. Let's hit graph to see if it's even in there. Before we do that, I want to go to window. Let's go to zoom and make it into Z standard just to see if it's in there, you know. So it's going to graph it up for us. The parabola is way up there. So what we're going to do, we're going to hit zoom and we're going to go to 3 so we can zoom out. And let's hit enter one more time. And we're not going to keep doing it this way, but I just want to show you how to find a vertex using your calculator. So to find your vertex, you're going to hit second in the trace button so you can get to calc. And you see where it says value, 0, maximum, minimum. We want to find, where is it? Oh, it looks like, Yeah. So let's go back to the graph for a second. Do we have a max or a min? You see how this calculator kind of makes a hill, right? As opposed to a U shape. A hill, you see that's a very tippy top right there? That is a maximum. So whenever you have a parabola that's upside down, that's a max. If you have a parabola that's right side up, which is a U, which is they call a valley, like a creek or something, that is a minimum. So we want to find what the maximum is. So hit second, calc. And this is, I'm just going to show you guys this one time. Let's go to max, because you probably can't even use the TI-84, but I figure I'll show you. It's asking you for the left bound, the leftmost point, or the left point of your vertex. So we're already here. You see the cursor. You can move the cursor from left to right. Let's hit enter. Right bound. Let's go to the right of our vertex. And that should be good enough. Anywhere is good. Hit enter. Anywhere to the right of the vertex is good. Right bound, hit enter. It's saying, do you want to guess? Yes, we want to guess. Hit enter. And now 3.9999, isn't it safe to call that a 4? So we're going to say this is 4 for your h, which is x, comma 24 for your k, which is y. So I'm going to say this is 4 comma 24. You see it wasn't exactly equals, right? But don't worry. 3.999 is pretty darn close to 4. So let's hit the coordinate 4 comma 24. What the heck did I do wrong? What did I do? Oh, I see a comma sitting there. We got it right. Don't worry. All right, excellent. So if you wanted to use negative b over 2a, you can. If you want to use the calculator, you can as well. But there's going to be plenty of practice here, so don't worry. Okay, use the vertex and intercepts to sketch the graph of the quadratic function. Give the equation for the parabola's axis of symmetry. Now, we didn't go over axis of symmetry, but it's very, very simple, I promise. I wonder if I should go back. Yeah. I'm going to write that for you guys. So let me just add another note here. Axis. Let's put it in orange. Axis of symmetry. The axis of symmetry is going to be a vertical dotted line, and you're going to see when we make it. It's a vertical dotted line. It's going to be x is equal to whatever your h is. So whatever you find your h to be, that's the axis of symmetry, okay? So just to give you a little idea of how it looks like. So you can imagine you have a parabola, right? Okay, that's a little crooked. So you can imagine you have a parabola like this. The axis of symmetry, remember this is your vertex, right? Let's say this is 1 comma 3 or something. Remember, your axis of symmetry is x equals to whatever your h is. What's your h here? The vertex here is 1 comma 3. So it's whatever your h is, x equals 1. So if you remember the equation of x equals 1 from way back, is basically a dotted line that's going vertical straight down a parabola just like that. So that fancy little thing is called the axis of symmetry, and they call it that because it splits the parabola in half, and it's almost like you have one section over here mirrored with this other section over here. So if you find one point, so if you can find this point, you go the same distance and you find that point. If you find that point, you go the same distance across and you find this point. That's the way I used to do parabolas all the time when I was young. Okay, but you can do it too. And we may do an example where we're just gonna utilize axis of symmetry. But that's all it is. It's x equals whatever your h is. That's it. So it's an equation. Don't just put the number. It's an actual equation. It's a dotted line. It's a vertical line. So it needs to be x equals some number. Anyway, all right, let's get back to business. So let's click on here. Vertex. Vertex comes first. What's the vertex here? It's the opposite of this, comma this. So 2, 3. So 2, 3. And now, we need another point. It says to use the vertex and intercept. So very, very specific. They want you to find an intercept of this. So what is an intercept again? An intercept is basically where the graph hits the x or the y-axis. So you can have an x-intercept or a y-intercept, right? So let's come over here for a second. And let me show you what I mean. So let's say you have a parabola like that. You know, we have an intercept here. That's an x-intercept because it's on the x-axis. We have an intercept here because it's hitting the x-axis again. And then we also have an intercept right here because it's hitting the y-axis. So you only need a vertex because we're doing this by hand on the computer, basically. You only need a vertex. You need this middle portion here, and either one of those points that you're going to see is going to make a nice fancy U for us, a parabola, a U shape. So, but we have to know a few things. So we have the vertex. We're at 2, 3, right? And now where do we go from here? How do we find the point where it hits the x or y axis? Well, you have two options. You can find a y-intercept, which is what I really prefer, because every single parabola will have a y-intercept. Everyone in this course, every single one will. Or you can find the x-intercepts, which is more difficult because you're going to make your y 0. You're going to solve for x. And depending on what we have, we may get a fraction. So listen, they said to use intercepts, but that's kind of misleading. We're going to use the y-intercept because if you have there's a good chance if you're looking for the x-intercept, it may be a fraction. And it will be useless to us because we can't plot fractions on some of these examples. So listen, it's y-intercept, okay? We're going to focus on the y. So remember, f of x is y technically, right? So I just want to stress something here. I'm going to erase the f of x and put a y. In my past video, you see I make the comparison and the contrast. Okay, so to find out what that y-intercept is, you plug in 0 for your x. What am I doing? So you can imagine having an xy table like this. We're plugging in 0 for your x and we're trying to get a y out. Okay, and whenever you plug a 0 into a variable, that means you're finding the intercept of the opposite variable. So if you're plugging in 0 for x, you're going to get a y-intercept. If you plug in 0 for y, you're going to get an x-intercept. And you can do that with any equation potentially. But anyway, so this is y equals 0 minus 2 is -2. -2 squared is 4. We have plus 3. So this is going to give us y is equal to 7, which means the y-intercept. Let me make sure you guys can even... Oh, I had the freaking calculator in front of you the whole time. Okay, here's what we have. Don't worry, you didn't miss much. So the y-intercept is going to be 0, 7. Remember, it's a coordinate. Your x was 0 and your y was 7. Okay, so let's go ahead and plot the darn thing. We've been on this question for a while. So let's go to 0, 7, which is right here, and call it a day. How about that? Bam. So we plot the vertex and the y-intercept, and we're good. It generates a nice little parabola for us. Axis of symmetry. Your axis of symmetry is always x equals to whatever your h is. Your h is the opposite of this guy here because of the formula right over here. It's the opposite because we have a negative in front of the formula. In the formula, I should say. So it's the opposite of this, which is 2. Domain. The domain of every single parabola in this course is going to be -infinity to +infinity. Okay, so easy points for that one. Range. Range is a little bit different. Range depends on your k. Okay, so very important. K is your y coordinate, right? It can either be a max or a min. So in this case, you see how this parabola shoots up to the sky like that? What is your y equal to right here? Your y is equal to 3, right? Isn't that what your k was? And if you were to keep going up, it's going to go off to infinity. So your range here, which is inclusive because it's solid there at that point, is going to be your k all the way to infinity. When you have an upside down parabola, you're going to see that we're going to have negative infinity to whatever your k is. So in either way, in either instance, you're going to be involving k with your range. All right, let's move right along. What do we got here? We have y minus 7 is equal to... Okay, so check this out first and foremost, right? That 7 does not belong there. So we got to move it over. So it's just a little manipulation, not too bad. We have y minus 7 is equal to parentheses x plus 2 squared, right? So we have to get the y by itself. Always make sure your y is isolated. So we're going to add the 7 to both sides. And so we get y is equal to x plus 2, the whole thing squared, and then plus 7 just like that. So it looks like this guy up here, the vertex form. So we're ready to rock, I think. I think it's safe to say. Since we're here, let's go ahead and write the vertex. The vertex is the opposite of this, which is -2, comma, whatever this is, 7, positive 7. This is your h, that's your k. You know what, since we're here, let's write down everything. You know they're going to ask us. The axis of symmetry, AOS, whatever. Axis of symmetry is x equal to whatever your h is, -2. It's that vertical dotted line. So you can imagine making an xy axis like that, 1, 2, and it's going to be a dotted line like that, okay? So that's for you guys in class. Okay, what else do we have? We have the domain. Well, we know that the domain is going to be negative infinity to positive infinity because that's true for all parabolas in this course. And last but not least is the range. If we're going to figure out the range, we have to know the direction of the parabola. So here's where we have the parabola equation, right? Where we got the y by itself, and that's where we judge, all right? And it depends on your k. So which way is this parabola going to open up or down? Well, your a term is positive. So the shape of the graph should look like that. It should be a U. So whatever this is going to be your k, which we already found the k. It's your k all the way to infinity. I'm hoping to give us a negative so you guys can have some practice. And we are ready to rock. Anyway, we're using the U, the parabola, because we're dealing with quadratics. We're basing this on what we have, what we got the y by itself. So we already wrote everything down. So -2, 7. Make sure it matches with the top right number here. So we should see a -2, 7 there. You see it changing? Yep, -2, 7. Did you want us to use intercepts again? Okay, so to find an intercept, I forgot to find the intercept. So make an XY table, put a 0 for X to see what your Y is. You can plug it anywhere you like. I'm going to plug it down here because we got the Y by itself. Because, once we get the Y by itself, that's the equation I really prefer to use. So Y is equal to 0 plus 2 squared plus 7. 2 squared is 4. 4 plus 7 is 11. So the y-intercept here is 11. It's an intercept, all right, but it's a y-intercept. So this is 0, 11, and we got it. That parabola is way up there. Weird. Excellent. Okay, axis of symmetry is x is equal to whatever your h is. We already found it, -2. Domain, easy points, -infinity to positive infinity. And make sure you don't put a bracket around infinity because a bracket implies that it's equal to, and you cannot technically be equal to infinity. What the heck is going on? Okay. I don't know what the heck was that about. All right, fantastic. Range, it goes up. So it's k to infinity with a bracket. So what's your k again? Our k is 7, and that's going to shoot all the way to infinity. Got it. Well done. Oh, that's it. That's good. Okay. All right. So moving right along. It says use the vertex and intercept to sketch the graph. Okay, so we got to get this in vertex form, and let me show you guys how to do that. Vertex form is the most useful to us. To be honest, you don't have to put it in vertex form if you don't want to. You can find everything you need here. Just do negative b over 2a to get your h, plug it in to get your k, plug in 0 to get your y-intercept, and that's really all you need, to be honest. So you don't have to put it in vertex form if you don't want to. So maybe we will be forced to, who knows? So we have f of x, we'll be ready. Right. Okay, so h, here h is negative b all over 2 times whatever your a is. Negative 2 divided by positive 2 is negative 1. So there's your h. Let's get your k. To get your k, you plug in whatever your h was. So we're just plugging in negative 1 into our function. That's negative 1 squared plus 2 times negative 1 minus 8. This is going to be negative 1 squared is positive 1. So 1 minus 2 minus 8. And I want to show you a little, an insider trick, right? An insider way of thinking for a mathematician such as yourself. Okay, if you plug in your h and you did negative b over 2a correctly, this term here, 1, should be half of your your second term every time. If it's not half of the second term, then you did something wrong. So if you get let's say you get a 15 here, this term over here should be 30 if you got the correct h. You know what I'm saying? If not, you can just keep doing what you're doing. Just do the math. 1 minus 2 is just a check and balance. 1 minus 2 is negative 1 minus 8 will give you negative 9. That's your k. So your vertex, I'm going to call it v, is your negative 1 comma negative 9. Axis of symmetry, you know, AOS is x equal to whatever your h is. What else would they ask us? Domain, I'm going to call it d, is negative infinity to infinity, easy points. And your range, is this parabola upside down or right side up? Remember, it depends on what your a is. Your a here is positive, so you're going to have a right side up parabola looking like that. So it's k to infinity. What's your k? Negative 9 to infinity. And I think that's all they really want from us, maybe. But we always want to be ready. So we have negative 1 comma negative 9 all the way down here. Got it. Oh, I always forget the darn intercept. You know what's good about this intercept? When you have it in this form, the standard form here, plugging in 0 is a cinch. Plug in 0 here, plus 2 times 0 minus 8. Because both of those go away, we're left with just the negative 8. And that's the intercept. So just on your y-axis, find negative 8 and click on it. Bam. Done. All right, well done. Axis of symmetry is x is equal to the negative 1. Fantastic. Domain, easy points. Got it. Range is, this is a right side up parabola, so it's k to infinity. What is your k equal to? And with a bracket, what is your k equal to? Negative 9 all the way to infinity. Excellent. All right, we're good. All right, we have some more nonsense. We have to do just a little bit of rearranging here, but you're gonna see it's not the end of the world. Okay, so how do we tackle this? I will show you. F of x. I'm sick of using red. Let's use blue. F of x is equal to, and check this out. I know we have 6x minus x squared minus 5, But remember, the standard form tells you to write it. Well, you probably wouldn't know. I mean, I didn't know the first time. Anyway, you want to write it in descending order, starting with the highest one first with the sign. So that negative x squared, we have to write it first. Then we have plus 6x. Then we have minus 5. So all we did was rearrange them, okay? So now what do we do? Well, we're ready to just jump in. Your h is equal to your negative b all over 2 times your a, which is negative 1. A negative divided by negative is a positive. 6 divided by 2 is 3, so your h is 3. To find your k, you plug in your h. So f of 3 is equal to negative 3 parentheses, yeah, you know. Remember, that should be half as that one, right? So that's going to give you a negative 9. Remember, square the 3 first and then keep the negative going. Over here, 6 times 3 is 18. Yeah, the first term is half of the second term. So I know we're getting this correct. So this is negative 9 plus 18, which is positive 9 minus 5. So this is going to give you a 4. So your k is 4. So we have our vertex is 3, 4. What is your axis of symmetry? It's x equal to whatever your h is. Domain, negative infinity to positive infinity. Tongue tie. Range, which way is this parabola going? We finally have a negative a. So this parabola is going to go down this way. And because it's going down this way, remember, you go from least to greatest. Now we have a case where it's negative infinity. And you keep going up to whatever your k is. And your k, what was your k again? Which is your y, right? Range deals with y. Your k is 4 because we have it here with a bracket. I'm not going to forget this time. We're going to find the y-intercept. So let me write y-intercept here. And we plug in 0. So f of 0 is equal to 6 times 0 minus 0 squared minus 5. So, you know, that goes away, you're left with negative 5. Okay, I think we have everything that they want. So we never had to switch it to vertex form. Some professors teach that, but it's not necessary every time. Maybe in the next one I will convert it to vertex form for you guys. Yeah, and there's 2 ways to do it. The best way to do it is to just find your h and your k, and you'll be good. And you know what? We could have done it here. Another time, next one. So 3, 4. Y-intercept is negative 5. Go straight to the negative 5 on your y-axis. We're done there. Excellent. That's it. Oh, no. Continue. Axis of symmetry. X is equal to whatever your h is, which is 3. Domain. This is negative infinity to positive infinity. Range is upside down. Whenever it's upside down, you might want to write this down, okay? Negative infinity up to whatever your k is with a bracket. And our k is 4. So you might want to write down, range can be tricky if you don't memorize it. All right, that's it. Yeah. Okay, so moving right along. Now, for this one, because of time, and as a matter of fact, give me 1 second because I know you guys are waiting on these videos. I'm uploading as we speak. Let me see if this thing uploaded. Sorry, give me a second. Just trying to see if it uploaded for you guys yet. Let me see. Go to content. I got to go to YouTube Studio dashboard, and it's uploaded. So the last video uploaded. So that's something to look forward to. Anyway, I'm going to use a calculator for this one. We know we can do negative b over 2a and do other stuff, but I want to use the calculator this time. You guys know how to do it. So, yeah, take your time with these. Let me turn on a calculator so you can see. And just for those who have a TI-84, this will be very, very helpful to you. Or a TI-83. So let's put the function in. We have 2x risen to the second power plus 4x, and then minus 7. Let's hit graph and see if we can spot it out. If as long as we can see the whole parabola, yeah, like that, then that means that we can hit second trace. And we're going to go to, this is a minimum because the parabola is a U shape. So what's the left bound? The left bound, just move the arrow over here to the left, hit enter, move the arrow over here to the right, hit enter, enter one more time. And the TI-84 calculator is Bay. Okay, it is Bay. Don't forget that. So we have the vertex. This is negative 0.99999. That's basically negative 1. And the vertex is negative 9. So we're going to, let's go ahead and put that inside of our function here. Okay. So the vertex is negative 1 comma negative 9. So negative 1 comma negative 9 is way right here. So negative 1 right there. Okay, let's plug in 0. You know, when it's in standard form, plugging in 0 is easy because you plug a 0 here for the x, plug a 0 here for the x here. You're going to get left with negative 7. So on your y-axis, make sure you go to negative 7. See how I did that? And like we're saving paper because I'm using the graphing calculator. Axis of symmetry, x is equal to whatever your h is. The h was negative 1. Good job. Domain, easy points. Negative infinity. To positive infinity. Range is your k all the way to infinity because it's going up towards the sky. All right, so it's your k, which with a bracket like that. K is negative 9 all the way to infinity. I keep misclicking. I don't know what's going on. Good job. That's it. All right, consider the function. Determine without graphing whether the function has a min or a max. Now, is this particular function going to be right side up or upside down? That is the real question. So let's erase this thing. Okay, so what is our a? The a here is going to be, the leading term is negative 2. So it's negative. So this parabola, the shape of the parabola should look something like that, upside down. By definition, because you have a ceiling, this is a max. So it definitely has a max. Well done. Now, the minimum maximum value is whatever your k is. It occurs at whatever your h is. X is h, right? So we have to figure out what the vertex is, basically. The max and min depends on your vertex. So the minimum value itself is whatever your k is, but where it occurs is at whatever your h is, and that's it. So let's go ahead and find that. We can do negative b over 2a again, or we can use the calculator. I don't want to go too calculator crazy. Some of you may not even be able to use it. Anyway, so h is equal to negative b over 2 times your a. Negative over negative is a positive. This is 2 times 2, which is 4. 12 divided by 4 is positive 3. Plug your 3 in into your function. And I know I'm being a little sloppy. So this is 3 squared, which is 9. That's negative 18. That better be a 36. And yes, it is. 12 times 3 is 36. Wink, wink, our little trick. Your answer when you do that would just be whatever your first term is, because it's half, right? Positive 18 minus 4 and 14. That's your k. So the maximum or minimum value is going to be whatever your k is. We know that this is a max, so it's 14. Where does it occur? Wherever your h is. Excellent. Domain, easy points. Range, negative infinity, because it's downwards, all the way to whatever your k is, 14. That's it. All right, your A is positive. It's going to be a min. It's a right side up parabola. Let me erase this. So your parabola should look like this. And it has a floor, so that is a min. Okay, it has a minimum. And oh, you want to make sure these are in order. Remember, descending order always. Because you don't want to put negative 2x first because you might think that it's a maximum. But anyway, this is a min. I'm hitting enter. It's not letting me do final check. Whatever, fantastic. Okay, vertex. Negative b over 2 times a. So that's going to be 2 over 2, which is 1. So it occurs at 1. Plug into 1. That's going to be 2 minus 2, which is 0. Look at that. No hands. Oh, I messed up. That's what I get. That's exactly what I get. So negative b over 2 times our a. Oh, 1/2. My bad. You know what? And just to be safe, let me redeem myself from that L I almost took. So f of x is equal to 2x squared minus 2x. This is negative b. H is equal to negative b. Okay, I didn't have to write it that large. It's your negative b divided by 2 times your a. I'm sorry, your a is 2. Yeah, tee-hee. Tee-hee. Negative times negative is a plus. This is 2 divided by 4, which is 1/2. Uh-oh, we got a fraction. Let's see if we can get away with some things. Let's plug this inside the function to get our k. This is 2 parentheses 1 over 2 squared minus 2 times 1 over 2. 1 over 2 squared, that's 1 over 2 times 1 over 2. You multiply straight across when you're dealing with fractions, right? Right. This is 2 times 1 over 4, which is 1/2. Minus 2 times 1/2 is just going to give you a 1. 1 over 2 minus 1 is going to give you negative 1 over 2. And that is our k. Okay, so it really occurs at 1 over 2 for your h, which is your x. And what is it? What is the max or min? Negative 1 over 2. Domain. Domain is negative infinity to positive infinity. Range. Which way does this parabola go? This parabola, the a is positive. Remember, this is 2x. This is 2x squared. So this is positive. So it goes up, which means it has a min, which means your range is k all the way to infinity. So it's k. So what is your k here again? Yeah, negative 1 over 2. All the way to infinity. And that's it. Okay, when will it end? How many questions do we have here, man? I'm not gonna lie, I'm starting to get a little slightly tired. They gave us a lot. All right, 16, we can do it. Only at 68%. Ain't that a mother? Okay. All right, let's do it. All right, give the domain and range of the quadratic function whose graph is described. Okay, the vertex is negative 3, negative 1. Parabola opens up like what we have over here. I'm just making sure you guys can even see. So it opens upwards. So it's your k to infinity for your range. Oops. Sorry, we never put a bracket there, right? Put a bracket here to infinity. So they gave us the k. The k is negative 1. We know the range. I'm sorry, we know the domain is this over here. Your range is your k to infinity because it opens up. So bracket, your k is negative 1 all the way to infinity. Oh, that's it. Give the domain and range again. Okay, the minimum is negative 3, and the x, which is your h, is x. That's quite nice. Did they tell us whether it opens up or down? Oh, they did say it was a minimum. So to be a minimum is just like this guy here, the right side of parabola, right? Isn't that a min? Because it has a floor. Remember, this is a ceiling, that's your max. This has a floor, so that's your min. Okay, so we already know the way the graph is going to look. The domain with every parabola in this course will be negative infinity, positive infinity. I sound like a broken record, right? Range is k to infinity with a bracket surrounding the k. The minimum is basically what your k is. They're synonymous. So to infinity. So make sure you make that connection. Max and min is basically your k. Okay, we're speeding through these. Okay, so take a look at here. An athlete, blah, 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 blah. All right, we have the function. That's all we really care about. Okay, what is the maximum height and where does it occur, basically? It says, how far from this point does it occur? Okay, maximum height is your k. Where it occurs, or which occurs, is going to be your h. So we have to figure out what the vertex is for this one. Now, we can do negative b over 2a, but we have to use a calculator for this one. And we're not going to go hardcore and use the function of the calculator. We're just going to go ahead and do the arithmetic. Yeah, let me get the calculator out. Okay, so very carefully, right? Let's go ahead and do negative b over 2a. So negative b, which is 1.4, divided by 2 times whatever your a is, which is negative 0.02. Let's close it up, hit enter. 35. This is where it occurs. So please do not put the maximum or minimum at 35. Okay, that's your x. That's your y. Your h. Now that we have our h, we plug that in to get our k. So let's go ahead and plug it into the function. We have negative 0.2. I'm sorry, 0.02. So let's change that into a 0. Parentheses. We're going to plug in the 35. Remember, we're just plugging in our h that we just got a little while ago. We're going to square it. Plus 1.4 times whatever your h is again. H is 35. And then plus 5.8. And that's going to give us our max 30.3. Yay, fantastic. What is the shot's maximum horizontal distance to the nearest tenth of a foot, or the distance of the throw? The maximum horizontal distance. It says x is the shot's horizontal distance in feet from his point. The maximum horizontal distance, that'll be from 0 all the way. They're asking for a domain, right? They're asking for the whole stretch of this graph going from left to right. They're asking you for a domain. However, we can't use negative infinity to positive infinity this time, can we? So here's what we're going to do. We're going to find, you see how over here we have an intercept, and over here we also have an intercept. To find those intercepts, we're going to use the function to our advantage. Now, what sucks, and I hate to say the word sucks, but what sucks is that we're going to have to factor this thing. It looks like it could be factorable. We can make it factorable. Man, yeah, they're pulling out the big guns. So here's what we're going to do. We're going to tweak this function up a little bit to make it more easy on the eyes. And because we have decimals everywhere, right? We don't want to have decimals everywhere. And then we're going to divide by a common factor and see what the heck happens. So, we're looking for the stretch. So if we can figure out what this point is here, that would give us our x. And so that would be all we need since it started from 0. So if I want to find that, that's the x-intercept, right? So to find an x-intercept, you make your y equal to 0. And yeah, we're bringing up the big gun. So if you see this problem, do exactly what I'm doing and you should be fine. I hope. Oh God, I hope. Okay. All right, here's my stylus. I'm tripping. Okay, so the original function is f of x is equal to negative 0.02 x squared plus 1.4 x plus 5.8. Let's tweak this problem a little bit. Oh, and we know we're going to substitute 0 in for your y so we can get the x-intercept. So I'm just going to erase the y, which is f of x. Remember, f of x and y are the same. I'm going to put a 0. Let's tweak this problem up a little bit. I don't like all these decimals sitting everywhere. Let's multiply everything by 100 so we can move 2 places to your right for each of them. So 1, 2, that'll be, and remember, you're doing the same thing to the 0. You're multiplying the 0 by 100 as well. But because it's 0, nothing happens. So 1, 2, that'll be 2x squared plus 1, 2, that'll be 140x. Then plus 1, 2, that'll be 580. Now take a look. What do they all have in common? Can we divide it by some number? Absolutely, we can divide everything by 2. So divide this by 2, you get x squared. Divide this by 2, you get 70x. Plus divide this by 2, half of 58. What is half of 58? 29. 290. Now take a look. We're going to attempt to factor this thing up. Now, you may be intimidated by this, depending on whether or not you watch my factoring video, or you may not. So we basically set it up like this. So refer to my factoring video. It's one of my first videos. We need to find factors of 290 that when you add them together will give you 70. So using my little trick, let's divide by 2, you get 145. Multiply by 2, you get 2. What can 145 be divided by? Can it be divided by 3 or 5? It can definitely be divided by 5, but remember the dot man method requires you to, that was my first video ever, by the way, the dot man method. It requires you to divide by the smallest number, and that's exactly what I'm going to do here. But can it be divided by 3? Well, is 1 plus 4 plus the 5 equal to a number that's divisible by 3? What's 1 plus 4? 1 plus 4 is 5. 5 plus 5 is 10. So no, 10 is not divisible by 3. So 145 is not divisible by 3. You add the individual digits and test. But it can be divided by 5, so give me a second to just divide that thing by 5. This goes in twice. 9. So this is 29. You divide by 5 to get 29. You multiply the other factor by 5 to get 10. And I'm not getting something that will give me a 7. Is 29 divisible by anything? I don't think so. So it looks like we can't add to get that. Let's go ahead. And looks like sadly, looks like we have to use the calculator for a second. Maybe I did something wrong. I don't know, but we have technology. Get it together, Dan. All right, put the same function in. So negative 0.02 x squared. Then we have plus 1.4 x plus 5.8. And let's see if this is gonna, what the heck is that? That should be an x. Anyways, let's see if we can see the vertex and everything. Not quite, so I'm gonna go ahead and zoom out just a little bit. So, oh, you guys can see the darn thing. So all I did, y equals, I put the whole function in with all the negatives and everything like that. And I just hit graph to see if we can see the whole parabola. Now we want to see the vertex looks like it's almost in there, but we want to zoom out even more. So let's zoom out. Yep, it's going back down. Now we want to find the intercept, and the calculator has a function for that. So let's hit second count. We're going to go to where it says 0. And the 0 is another word for x-intercept. Okay, so they want the left bound of that intercept, which is here. They want the right bound of that intercept, which is down here. And I don't know why it didn't work for us. Let's hit enter again. Oh, because it comes out as a darn decimal. That's why. So we were supposed to use the quadratic formula, guys. Okay. And It wasn't factorable. So, we still got it. Nearest 10th will be 73.9. And let us rejoice. So, use the quadratic formula. From what height was the shot release? That's the y-intercept. So just plug in 0 into your function. That would give you your original height that you're starting from. Remember, it says shot put's height. So just plug in 0. What do you get? You get the 5.8 when you plug in the 2 zeros into the x's. They cancel. Anything else? Okay, you don't want anything else. Good. Yay. Okay, so for that one, you're going to use the quadratic formula, okay? Excuse me. Okay, so to give us another function, you know what's going to happen next. They want the max and min. You can do negative b over 2a, all that good stuff, and put it inside your calculator. You can manipulate this function a little bit by multiplying everything by 10. And you know what? I want to do that. I want to do that for you. I don't want to just use technology. I want you to understand this stuff. So I'll do that for you. Why not? So f of x is equal to negative 0.1 x squared plus 0.7x and then plus 8. You know, I think I know what happened in the last problem. I left that thing as a negative. I think I left it as a negative, yeah. I bet that's exactly what happened. It may not have changed it. Anyway, yeah. That's me thinking back. Anyway, negative b over 2a. So it's negative b divided by 2 times your a. Looks like we were forced to use a calculator here in this case. Remember, this is your h. Looks like we have to use a calculator, sadly. So let me turn on the calculator. So negative b divided by your 2 times whatever your a is. Enter 3.5, 3.5. So this is where it occurs at positive 3.5. To get your k, you're gonna plug in the 3.5. So yeah, let's plug it in. So we have negative 0.1, open parentheses, 3.5, close parentheses, square it, plus 0.7 times 3.5, and then plus 8. That's your k, 9.225. Did he want us to round? Yeah, nearest 10th, 9.2. Excellent. How far does the ball travel horizontally before hitting the ground? In other words, what is the x-intercept of this one? Now, the only way you can find it is if you do the quadratic formula, and I promised that I would at least do one of those without the calculator function, that is. We're still going to have to use a calculator because we may have a radical. So let's go ahead and set it up. So you know what? You don't have to manipulate the function if you don't want to. Nah, we're going to manipulate the hell out of it. So remember, this is these are intercepts you're looking for. So your y is 0. Your f of x is equal to 0. This is negative 0.1 x squared, and I'm not going to make the mistake of leaving it as a negative. I don't even know if I did or I didn't. I have to look at the video, obviously. But here's what you're supposed to do. Your leading term should never be negative if you can help it. So we're going to change all the signs. That'll be 0.1 x squared minus 0.7x minus 8. You don't have to do it. I personally like to. So, we're going to keep on going. This is our A. Oh, no. Let's manipulate it just a little bit further. I don't like decimals like that. I know you don't. I don't as well. So let's move one place every decimal to your right, which means we're multiplying everything by 10. So that will give you x squared minus 7x minus 80. Is that factorable? Let's see. Let's use the dot man method really quick. Divide by 2, multiply by 2. divide by 2, multiply by 2, divide by 2, multiply by 2, divide by 2, multiply by 2. Can't do anything else over here. Divide by 2. Yeah, that's all the factors of 80. None of them will give you a 7 when you subtract them, right? So it's not factorable, but whatever. So this is going to be a good old-fashioned quadratic formula question. So A is equal to 1, B is equal to -7, C is equal to -80. And you may remember from my last video, X is equal to -B plus or minus big old square root B squared minus 4 times your A times your C all over 2A. And just bear with me here. So this is -B plus or minus big old square root B squared. I'm going to say that's 49. -7 squared is 49 minus 4 times your A times your C all over 2A. Now go ahead and be a good little lad or a good lass and plug all that stuff in your calculator. Me, ain't nobody got time for that. You plug it in, you'll get everything right, okay? And I know you know how to plug into your calculator, but for us cool kids over here, I'm going to go ahead and use my TI-84 again. Oh, was it off the whole time? Yes, it was. Some of the screen was cut off. All right, that's a major fail. I'm going to have to redo this video sometime in the future. But anyway, that's so lame. Okay, is this the same function from the original? I don't think so. -0. Yeah. So when you do the quadratic formula, you're going to get the answer, so don't worry. -0.1, we have x squared plus 0.7 times your x, and then plus 8. Let's hit graph to see if we can get the intercepts. It's pretty, yeah, we're going to get it. All right, so you go to second calculate. We're going to choose the 0 option because that is the x-intercept. Left bound, I think over here is safe. Hit enter. Let's go to right bound. Enter. Guess. Bam. 13.1. Nearest 10th. 13.1. Let's do it. 13.1. Got it. Excellent. This crap. All right, we already have the graph here. If you didn't have the graph, you would know that this is an upside down parabola because we have a negative in front, so it has to be upside down, and they all are upside down. And basically, you just match up the vertex and match up the intercept, and it says horizontally before hitting the ground. That's the x-intercept, so just match the numbers up. Your vertex should be 3.5, 9.2. So that looks like it could be it there. It's definitely not this one because the middle of that parabola is at 10. So that can't be it. 3.5. It could be that one. It could even be that one because the 3.5s match up. What about the max, which is 9.2? That could be it. The max here is exactly, it looks like it's 10. So that, I don't think that's going to be it. The max here is not 9.2. And neither is that one. Process of elimination. It's got to be our boy A or our girl A. And that's it. See how I did that? Is this the last question? Yes, it is. Finally. Okay, Farmer Ed has 150 meters of fencing and wants to enclose a rectangular plot that borders on a river. If Farmer Ed does not fence the side along the river, find the length and width of the plot that will maximize the area. What is the largest area that can be enclosed? Find the length and width of the plot. So we're going to have to figure out what our x is, basically, because the x looks like the x is going to be our width because it's shorter, and the width is going to be whatever 150 minus 2x is, which is our length. So we want to find out what will they use the word maximize. So basically, we're going to find the vertex. Whenever they say max or min or highest or lowest, that's vertex talk. Okay, so let's go ahead and do it. And I don't think we need the calculator for this one, so let's turn it off. Okay, so what do we got? What do we got? What do we got? we have, okay, so we're talking about maximum area, right? Remember that area is equal to the length times the width in the good old days of algebra, or before algebra was brought to us. It's length times width. So we're going to find the function, the area function, basically. The function that describes the area. So you take your length, which is 150 times, what is that? Let me move this out of the way. 150 minus 2x, sorry, times your width is just x. So this is your area, and now we basically just multiply everything on out. You could have done x times 150 minus 2x and say this is width times length. You can do that or not. It's up to you. As long as you multiply them. 150 times x is 150x. Minus 2x times x is negative 2x squared. And look, we have a nice little quadratic, all because we have our highest term as x squared. Let's rearrange this. This is negative 2x squared plus 150. And this is the area. So the width is going to, they want you to find the length and width of the plot that will maximize the area. That is vertex talk when they're talking about max and min stuff, right? Remember all those questions that we just did? All right, so our h is going to be negative b over 2a. So, am I missing something? Yes, I am. I forgot to multiply the x with the 150. I wonder if I said it and didn't write it. So this is your a term, negative 2. This is your b. And notice that there isn't a constant flowing around, so that's not going to be your c. So anyway, let's get going. Negative b divided by 2 times whatever your a is. So effectively, this is negative 150 divided by 4. I'm going to cheat and use my calculator because you divide it by 2, you get 75. Divide by another 2, I don't know what that is. Or I just don't feel like it. So divided by 4, 37.5. 37.5. Oh, and a negative over negative is a positive. So this is our h. And let's see if they're going to ask us about the other stuff. I'm sure they will. So 30, or not, maybe 37.5. This is a 3-parter. Nice work. Okay, just plug your 37.5, what you got for x, and plug it right in there. You take 37.5 times 2. Yeah, let's just plug it in. I'm using my calculator, so 150. I know you can't see it. 150 minus 2 times, we're going to plug in the 37.5, 37.5. Look, you get 75. We already had that, 75. I did that in my head a little while ago. Okay, the largest area that can be enclosed, basically you take the length and width that you just found and you multiply them together. So we take 37.5 and you're going to multiply by 75. And you know, let me turn on the darn calculator so you guys can see what I'm doing. That's not fair to you guys. So here are all the calculations that I did with the negative b over 2a, and then I start plugging numbers in. All right, sorry about that. Let's hit enter. Wow, 2812.5. They wanted a decimal. So 2812.5. Well done. That is it. We got our 100. There's one more video left. These things take a while. Please like, comment, and subscribe if you like. If you don't, if you feel like. Thank you so very much for watching. Thanks again to my subscribers. You guys are making this channel boom. I have like close to like 40 something watch hours. It's insane. All right. Thank you so much, and go home.